Okay, so here, let's try. So since this, okay, since we identify that the angle of intersection is not 90 degrees or not equal to 90 degrees, then the trajectory is isogonal. So we already know that is 45 degrees. So we will be using this solution for the slope. Tangent theta or tangent P is equal to slope 1 minus slope 2 over 1 plus slope 1 times slope 2. So we have 1 plus m1 m2. So now, sir, what is m1 and what is m2? Okay. The slope 1 is the slope of your trajectory. Okay? That is the slope of the trajectory. While the slope 2 is the slope of your given curve. So, we already solve the slope of the given curve, which is this one below. Okay? So, mani siya. So, we have to get the slope of the given trajectory. But since we don't have the exact, or we don't have the equation for the trajectory, then we could say that the slope of the trajectory is just still equal to dy over dx, since that is the slope, di ba? dy over dx. Okay, again, in the trajectory, from the given, that is not present. So, wala na sa ato ang given. So, that's why we represent it as dy over dx, because that is the slope. While our slope 2, since we already have the exact value of our slope 2, which is negative x over negative y. And our p is 45 degrees from the given problem. Okay. So, now, we will try to substitute. Okay. So, we have here tangent 45 degrees, okay, equals the slope 1. So, slope 1 is our trajectory, which we don't know, dy over dx, minus the slope 2 is our negative x over y, which is the slope of the circle, or the slope of the given curve. So, plus 1 plus dy over dx times negative x over y. Okay? So hopefully you still remember this one. Okay. Now, if you use your calculator, you have tangent 45 degrees, that will be equivalent to 1. Okay? Tangent 45 degrees is equal to 1. So, now, so we have 1, we can transpose this 1 to the other side. So you will have 1 times 1 plus, so okay, so we have now negative times positive, we have negative x over y dy over dx, right, equals dy over dx plus x over y. So now, when you multiply this one, you'll just have this 1 minus x over y dy over dx equals dy over dx plus x over y. So from here, let me clear some of this. Okay, so maybe this part. Okay, let me clear this part first. Okay, then this part. So we'll not erase this one. Okay, so now let's continue up here. Okay, let's get oops, brush. Let's continue up here. Okay, so from here, so okay, sorry, it should be here. Okay, so from here, okay, so from here, we now look into the common. So from here, we have dy over dx, dy over dx. So iuban lang nato. Okay, so we have 1 here. I transpose the negative x over y dy over dx to the other side. and this one to the other side, the x over y. So you have x over y equals dy over dx plus x over y dy over dx. Sir, how does it happen? I've just transposed this negative x over y dy to the other side. So we have dy over dx plus x over y plus x over y dy over dx. Now, since I have dy over dx on the both sides, and here I have xy, so I just transfer the positive xy to the other side, so it becomes negative xy. So I just combine the dy over dx. So from here, so I have 1 minus x over y equals common, so we have 1 plus x over y times dy over dx. So I have this one. So our slope dy over dx is just equal to 1 minus x over y over 1 plus x over y. Or we could simplify this further as dy over dx is equivalent to, so we have the common denominator, common denominator of this, that is y. So y divided by 1, so this is 1 over 1. Y divided by 1, that is y, times 1, that is y. So y divided by y, that is 1, times x, that is x. Okay? Over, same. You have y divided by 1, so because that is over 1, okay, muna na siya over 1, yan na. Okay. So, y divided by the 1 here, that is 1, times the 1, you have y. Y divided by y, that is 1, times x, that is x. So, from here, you could cancel this one, right? Because for the others who still confused with the algebra, this is just simply dy over dx equals y minus x over y times, transpose this one, you have y over y plus x. So, that's why it cancelled. Okay? So, muna siya. Okay. That's how it happens. Okay. So, from there, let me erase it. Let me erase this solution. So, we can continue. Okay. Now, so from here, okay, brush. So from here, let's go up here. Okay. So from here, so we only left with dy over dx is equal to y minus x over y plus x. So from here, we could just cross multiply so that we could integrate it already. So we can cross multiply, so we have y plus x times dy equals y minus x times dx. Or we could form this one as our first order, first degree differential equation, which is mu of xy dx plus n of xy dy equals 0. So we start with x, so we have y minus x dx. Transpose this, transfer this one to the other side. You have negative y plus x dy equals 0. So if you could see here, So from here, you have this one. Okay? So my y and my dx. So from there, so this given differential equation, so this is your differential equation. This could be solved by using, okay, let's see, could we use variable separable? Obviously, the answer is no. This problem is not a linear differential equation. This problem obviously not Bernoulli, and obviously not simultaneous. So this problem could only be exact differential equation or homogeneous. Let's try if we could use exact. From here, I've used homogeneous. So if that is exact, so with respect to y, so this becomes derivative y, that is 1, and derivative of a constant, that is 0, right? So if you derive y, that is 1. Derive x, that is 0. So if we derive respect to x, that is negative man na siya, no? Negative. So negative, that is derive y, that is 1 times negative, negative 1. So derive negative x, that is 0. So therefore, this is not exact differential equation. So therefore, what remains is a homogeneous differential equation. So now, again, we could choose either x or y. So here I've used vx. So this problem is just a simple homogeneous differential equation problem. So it's either x or y, you will have the same process. Okay. So in here, I've used homogeneous in y. You could try homogeneous in x. So from here, so we know the process of homogeneous. We derive this one, dy is equivalent to v, derive the second one, dx, plus copy the second one, derive the first, dv. Now, substitute this one to your given differential equation. So we have y, which is vx minus x dx minus y is vx plus x dy is v dx plus x dv equals 0. So from there, so distribute, you have vx, so yeah, vx dx minus x dx minus, so you have negative vx times v, you have v squared x dx. Next one, vx times x, we have plus vx squared dv. Okay, let's continue. So from now, we can now get this one. So this one, x plus xv dx, x times x dv, that is x squared dv equals 0. So now you have vx dx minus x dx minus v squared x dx plus, that is minus. So multiply the negative. So you have vx squared dv minus xv dx minus x squared dv equals 0. So look if we could cancel something. Okay, we can cancel this one. This one, we could cancel this one, right? So the vx dx, xv dv, we could cancel this one. So therefore,